Can you see my screen? Yeah.
No.
No, yeah. Why is this always with technical difficulty? Start sharing. Start sharing. Any screen? Yeah. Okay. So event scheduler. It's just like in HYSYS. I just did this very simple event schedule. We just go through the Excel file, and then later on we'll go on the file itself. So I think before I do so, I better just share the file. Yeah. Then move, share. Okay. So that's the file. Nonetheless, we'll just go through this, and then we'll see. So it's a very simple one. It's just like we have incoming 10,000 kilogram an hour, and then we have what we call like a shutdown valve. So we can rename this accordingly and more appropriately. And then we have a flow control valve. So I think it's controlling the flow rate to be like about this 10,000 kilogram an hour. So it enters the vessel, and then the vapor part will go to the top. Yeah, it's a pressure controlled at yeah, 40 kilogram per square centimeter gauge. I don't normally use this kind of unit, but I don't know. And then we have a level control. So we have a level control over here, and then in this liquid line, I just like a simulate what if we have like a leakage for something. Yeah. So this is just like a T line, and the valve is closed, so it is now at 0 kilogram an hour. So there's no leakage in the line, basically. So we have pressure control, typically very simple flow control, pressure control, and level control in this manner. Yeah, so we have this a very simple setup just to get the understanding very clear. So the event scheduler, when I see this event scheduler in HYSYS, they have like a schedule manager, and then in the schedule manager we can just make many schedules. Yeah, you can develop your own scenarios, and then for example this scenario one, for example, or schedule one, whatever, and then we have this sequence A, and then it has this is a kind of a diagram to make us understand what it is actually on how we can use this. So we have a sequence A, and then in this sequence A, we can then you can rename it. For example, sequence A is then yeah, I don't know, maybe some like a pump failure, or like a tank leakage or whatnot. And then within this sequence A, we can then define what are the events that are happening in this sequence. For example, if it's like a pump failure, if the name is then pump failures, that means we have to then select. So for example, yeah, after running this for 500 seconds or 100 seconds, for example, that pump will then be switched off. So this is then the first event, the pump switching off. And then what is then the condition is that, like for example, 200 seconds, pump will then switch off. And then after this pump switched off, what is then going to happen? For example, the any valve will then close, and so on and so forth. Yeah. So what I did here in this example, we have a sequence A. I should rename this accordingly, but nonetheless, so this LCV open means this LCV opens. What did I do? So it's just like the one event is then LCV open, and then the second event is then the L level drops. That's how I name this. And then we can see what is then happening. So in this particular case, so this is see, I wrongly named this. So in this particular case, what I meant is that at a certain time we have a leakage, so that means this valve will open. So that's my event. Yeah, so the event is that this valve will open, signaling that there is a leakage somewhere in the pipe. So that's what it means. So please do not follow the naming. So the naming is wrong, so you can just rename it as like a leakage. And then what happens, so at 5 minutes, for example, I put this a specific simulation time. So when we run the simulation at 5 minutes, this event will happen. And what this event is, yeah, the condition, you can go back to go to the tab condition, specify 5 minutes, and then rename this accordingly. And then what is happening, we go to the action list. So in this action list, we say that these VLV 100, which is this one, VLV 100. So this VLV 100, it's now it is closed, but then later on it will be 100% open. You can see this 100%. Current value is closed because now it's closed. Zero, current value is 0 because now it's closed. But then after 5 minutes of the running simulation, it will be opening 100%. So that's what it means, yeah. So after 5 minutes, it will have leakage. I don't remember how big this valve is, but then yeah, you can size your valve accordingly to make it like a leakage or burst or whatnot. And then if the valve is then open, yeah, when the valve is open, so that means it will see a drop in the level of the liquid, right? It will see a drop in the liquid level. This guy will sense this, will sense it, yeah. So it says the liquid level drops, it will then try to close this LCV because this LCV is still working fine. So it will close this LCV, but since the leakage is somewhere in the line, yeah, so the level still drops until a certain level, yeah, until a certain level which I set here. So when the level is drop, yeah, so I add another variable. So liquid percentage level currently 50%. So if this level var1 is less than 30%, yeah, I put this less than 30. Okay, and then I will then, what happens, I will then put an action list as the feed close. So feed close means we have this shutdown valve VLV 101. VLV 101, what is that? So this VLV 101. So when the level drops to 30%, we don't want to lose any more valuable materials. So this valve will close. Yeah, so this valve will close, and then we have the liquid contained in the upstream. So there's whatever liquids that is over here, let it be leaking out, but then we make sure that we have contained the liquid from the upstream. So that's basically the simple case what I made. So this valve, which is now 100%, it has to be closed 0% when the liquid level is less than 30%. Yeah, so we select this when the logic to evaluate if it is true. This is specify a simulation time. So 5 minutes. We have the leakage, and then when the leakage leads to the a drop in the level to 30%, I will have to close or shut down the valve. So it's a bit more automatic in this particular case. And then we run the simulation, and then this is how we get this. Yeah, we'll run through this very quickly, and then we'll go to the simulation. Red one is then FCV. We know the FCV, yeah, is the FCV. The green one is then PCV, blue one LCV. VLV 100 is the leakage, and then VLV 101 is then the shutdown valve. So what we see at 5 minutes, so this is 5 minutes. At 5 minutes, the VLV 100, it was 0, and then at 5 minutes we have some lagging, so it's in the valve data sheet. So there's a lagging, but then at 5 minutes it will then open 100%. So you can see this dark black line. 5 minutes it opens 100%, and then that will then create a lower in the level. Level is not shown here. Level is shown. Level is shown here over here, the blue one. So this blue one, so it will have a decrease in the level. Yeah? So when the level drops until 30%, I think 20, 40, and 30% is somewhere here. When the level drops at 30%, the which is somewhere around 6 minutes something, we have the V101 will then be closed. So this V101, the purple one, and the purple one, this is, which color is this?
Pink.
Pink. Sorry. So this pink at around 6 to 7 minutes, where the level drops to 30%. Yeah, in this at this point, um, this pink will then close. See, 6 to 7 minutes, it will then close automatically to shut off the liquid's flow rate, or the feed stream coming into the vessel. So that's what is happening basically. I have this case, so let's open the case. um, oh, I need to share you the starting case so that you can see it. Minute, yeah. Starting case. Let's see. So hopefully it runs well, yeah, this time. At least in accordance to the flowchart that I've made. Not like last time. So while waiting, do you have any question? Does anybody have any question?
Have a question.
Yeah.
Regarding the in real life, this valve, the one without control.
This one.
Gate valve. This one, the one BLB 101, as well as BLB 100. Is it gate valve or blue valve? Is it used to control the rate or just isolate?
This one is to isolate. Yeah, this is just like a dummy to simulate the leakage. But this one, if we think of it like a shutdown valve, it has to be like a fast acting valve. Yeah, in this
particular gate valve.
In this particular case, we have to discuss it with vendor. But in some cases, it gate valve, but I see it more often than not. It's a like a butterfly valve. I think I saw it more. Yeah, it's my own experience. Maybe in some people they see gate valve, but because this is the knowledge of the vendor, because they know for each of the valve, depending on their size, how much is then the closing time, which they can control. So it gate valve, you have no, like for example, there is no obstruction in the flow rate, but with the butterfly valve we have some obstruction in the flow rate. But in this case, well, you could select for gate valve or butterfly valve. It doesn't really matter, but it has to be the what is more important is that it has to be a fast acting valve. It has to be closed very fast.
Okay.
Yeah, I mean, but that is also depends. Yeah, in some cases, if it closes very fast, if we have like a long line here in the upstream, you have a long line and it continuously coming, and then if we close this very fast, it will have like what we call something like a water hammer. It will hit this valve, and then it will then it will then create a pressure wave. So it can that pressure wave, depending on the design pressure of the pipe and then everything around it. So if that pressure wave is higher than the design pressure of the pipe, and then that pipe can burst. So in some cases we did some simulation in such a way that instead of making it fast, we make it slightly slower, in such a way that the created pressure wave is not exceeding the design pressure of the line. Am I clear?
Yeah, so the point of the valve is purely for isolation, not for controlling.
Yeah, exactly. Yeah. So this is typically you will see on the fields also, like we have a separate it has to be separate, yeah, because this is for safety. This is for basic process control system, or BPCS. So we cannot use this as a safety, because it has to be an independent, what they call like an independent protection layer. So this has to be an independent system compared to this guy.
All right.
Okay. Any other questions? So we'll see this. Yeah. So this, I think you see that. So in this particular case, we have this actuator. So it has this linear rate 1% per second. Yeah, the opening of the valve. So it has 1 second of time constant. To see how they are being calculated in HYSYS, we have to go to the help file. But we can see it that because of this constants, it has this kind of, you can see this delay. Yeah? So for 5 minutes, it has this time. So I think it's it may take some time.
Less than a minute.
Yeah, it's less than half, but maybe like 1/4 of the minute. But for sure it's less than a minute. Where was I? Okay, this one. Yeah, and then we have FCV 50% now. Okay. Where is my where is that thingy? Dynamic strip chart. This is what I was looking for. What do we want to see? I think yeah, you can see all. Yeah. Now before we see this, I'll just see this event scheduler. Event scheduler is in Dynamics as well. We can see this event scheduler. Yeah, so we click on this, and then it gives us this page. So in this case, we can have one sequence, for example, and so we can name it as sequence A, and then we can add some more sequence to it. Okay, and then in this one sequence, and then we have these two events happening. So the first event is then bypass open, and then so in this this sequence, we go to the sequence, and then we can then add any events that are happening during this sequence, basically. So number one is then I enable this bypass open. So we'll then either double click on this, and then it gives us this pop-up window, and at 5 minutes, yeah, hour, minutes, and then seconds. At 5 minutes, it's a rename already, bypass open. Yeah, at 5 minutes, what is then going to happen? This bypass will open. So bypass open, and then we've specified the variable, and then this valve 101. Yeah, we can just select target valve 101. And then it is now 0 or close, and then it will then be opened completely. And then the second event that is coming, which is then the variable one. So we can just add or delete variables according to what we want to have. So variable 1 v100, it is now 50% somehow, and then sorry, this is liquid percent. Yeah, it's control, so it's not. So this v1, the separator, I thought the separator. So it is now 50%. So if the variable is then less than this var1 less than 30%, this valve 101 VLV 101, it has to close from 100% currently to 0%. So that's at least the simple conditions that we can play around. Yeah. Also in here we can see it's okay, green okay means it's fully specified already. And then this blue like this, it's a waiting, yeah, because it is waiting for a variable to a variable, this variable to be this logic to be met, yeah. And then this bypass open, this is then it's running now. Well, it's running. I mean, it's in the running mode. If we then run this uh, how to call it, the dynamic simulation. Um, let's see. Sequence A is then the waiting, yeah. So I think do I need to do something? No, no, yeah. I think it's good to go. Okay. So when we so it's waiting for it to happen, yeah. So what is going to happen is then this 5 minutes to happen. Integrator 0, we have this, I simulate this only like until 30 minutes of 1800 seconds, yeah, 30 minutes, and then at 5 minutes we have the event is coming. I have now the valve. I need to have the legend so that we can see it. And then we have the liquid. Oh, this is the flow rate. Flow rate is not really important. So the pressure. Legend. Okay. And then we will run this. I activate the real time, and then I real time factor is 20 times. So it's if I don't put this 20 times, 1 second in here in the simulation is then going to be the same 1 second in our life, which is then if it's 30 minutes, and then we have to wait for the simulation for 30 minutes. So that is not healthy. So we have to if I don't tick that, if I don't tick this real time, it will be, the simulation will then run as fast as my computer can run. So it's also not very healthy, because then we will not be able to see like the how do you call it, the changes very nicely. So hence I put this 20 times faster, 20 times faster than the real life, yeah. So let's start. Event scheduler, I think because I need to see see, we can see together how these symbols are now going to change, yeah. It's 2 minutes, 3 minutes, 4 minutes, and then 5 minutes. So this valve, so it's now changing. Okay. So all sequence, all events are now complete. This is complete, that is, this event is complete. And then we can see the same situation as what I've showed you in the slides, basically. So the purple one in this case then the okay, something happens nonetheless. The Oh, it's because it's we close already the valve. We close already the valve, so it's stopped at 15 minutes. Yeah, because when we close the valve here, there is no more liquid coming into. There's no more streams, materials coming into these vessels, and then hence it cannot calculate the flash. And then we have this, and then the simulation just stopped because of this numerical problem, basically. Okay, but you get the point. Yeah, there's no more material coming here, and then hence it cannot calculate the flash, and then it will just stop the simulation because there is no numbers to calculate. It just tells us to stop. So I, instead of 30 minutes, I better then stop it like 15 minutes or something. But nonetheless, you get the idea of how, at least on how we can then specify this event scheduler in a simple manner. Yeah, there are many options in there are many things that we can specify in HYSYS, but I haven't gone through all kinds of possibility. Yeah, because you could add this start sequence, stop sequence, play sound, even if you want to like alarm or something, and then whatever this is. Yeah, so it's if you are later on going to work in the a kind of like an trading simulator program, OTS. So that means we have to accustom ourselves with these kinds of yeah, navigation window, so to say. So up until here, is there any question?
No question from
No
me.
questions, yeah. So it's very clear. So from the others, otherwise you can just play around. Yeah, you can open this file, for example, this simple v1 file as a starting case, and then you can create your own event, and then you can share it later if you want.
All right.
Yeah. What else? Yeah. Or you want to do
Doctor,
you want to do it now? Well, it's all up to you. So we have like 30 minutes.
Doctor, you can share also the news with them regarding symmetry.
Oh, the because there was a request last week on the because technically, yeah, for basic process simulation, I don't have anything to teach anymore. It's just like more repetition, so you can do more exercises. You can develop more simulations for with the various kinds of chemical plants or refineries, but the basic principle is just the same. We study the process. We get acquaintance with the components and the compositions, and then the operating conditions, and then based on this information, we can then fairly select the appropriate thermodynamic model. Um, and then we make the develop the simulation, and then yeah, once we get the simulations, you make it nice and robust, and then we do like a sensitivity analysis and optimization, and then some techno-economic analysis, because that's basically, these are the goals of why we do process simulation. Yeah, so the goals is more or less like we can do like a problem solving, troubleshooting. We can do like a sensitivity analysis, we can do like optimization, we can do techno-economic analysis if we have a new process to be developed. So these are the things that we normally do. uh, um, um, the reasons why we have to do process simulations, basically. So technically all the basic skills are there already, so I've shared with you. It's just like a more on like you do it more and more, and then you become, yeah, fluent and familiar, and then there's nothing else to teach, basically. Yeah, the rest is just like you go on the help, and then just try and error, to see how you can then make yourself a master in HYSYS or in other simulation software. So based on that, there was a request last week on the let's just do symmetry, right? I mean, just it's a different tool. but it's just basically the same like HYSYS. This symmetry. So in here in HYSYS, we see this kind of a flow sheet, but then in Symmetry they are using a Visio. They are utilizing Visio to make the graphic much more nicer in such a way, so that when we print it, it looks already more like a process flow diagram that we typically see in engineering documents, basically. This Symmetry is owned by I think you know this company, by a company called Schlumberger, and then the software is mainly used in North America, and also I think in Japan as well. And Petronas is using this software Symmetry. We call it Icon Symmetry. um, so I think it's if you request to do so, let's do so. And then but in this case it will be, because the Symmetry it's an official software, yeah. So they can give like a free license for education. So this session of Symmetry is going to be organized by Schlumberger Indonesia. So they are going to broadcast this to like yeah, Indonesian people. So it will be, I don't know, yeah, it will be in Indonesian language, in Bahasa Indonesia. I've never teach any courses in Bahasa Indonesia, to be honest. So I will see how I can do that, because there are many terms, that are in English, and I don't think we have the synonym of these words, or the translations of these words, many of these words in Bahasa Indonesia. So I'm also very excited and curious to know how I can deliver these courses in Bahasa Indonesia. So we'll see. You are very much welcome to join. I think you should join as well. Yeah, just like I will redo the basic understanding and knowledge on how to do the process simulation. So you will hear this the second time, but in that sense, it will then make this uh, like a more permanent in the brain, right? But the same approach is just like using different software. That's basically what it is. So it will be, there will be like an official announcement. It's going to be like, because this free license, it's not going to we cannot have this forever. This free license can only be like, we can only do this like a 6 sessions in series, really consecutive sessions in series. So each session would be in 2 hours time, roughly, yeah. 2 hours time, so 2 hours times 6, it's about 12 hours of process simulation work. We will redo this, I think I will just use the same case like DME case, so that because it's a very simple case, and then you can grasp the idea very much faster. So once you understand the basic, and then you can do more complicated stuff. That is always my philosophy on how to learn things. So we start with the basic, we get the understanding robust and correct, and then we can always move on to more complicated situations. So that's basically the update from my side. You will hear, I will share with you the information, yeah, don't worry. But that's about the Symmetry. I think it's going to be like in 2 weeks time, maybe, I don't know. I will share with you. But then as of HYSYS is concerned, I don't have anything else to teach you or to share with you. The rest is just like you can do it on your own. I've shown you how to do it, yeah. Oh, energy analyzer maybe, but that's about pinch analysis. Yeah, but up to you. If you want to have it, and then we can have it. If not, then
Yes, we can have it.
if you want to have it, okay, then we'll see. Maybe before or after the Symmetry sessions, then we can have this exponent
Alright.
energy analyzer. But it's a more, I think for that I need to do more heat integration course first, yeah, without using any software, and then we go for the using these HYSYS basically. Oh, it's not HYSYS, it's Aspen Energy Analyzer.
Is it something similar to hint?
It's supposed to be much more powerful than hint. Uh, because hint is just like a free education software. Yeah,
Yeah.
in 2006, and then they don't maintain it. It's just like a free education software to teach, and that's it. But Aspen Analyzer is it will feel like this flow sheet that you are now seeing. It's a bit difficult to navigate here, if you ask me. But then it has the capability on like doing optimizing heat exchanger network design. So that's basically it has that capability, but it doesn't mean that it can solve all problems for you. Nah,
Alright.
we will see it when we see it later on.
Alright.
But for that, I don't know how many of you is there like how many Shafiq, yeah? How many of you are 6 people now, yeah? Any of you have done or have yeah have done this heat integration course? Because I need to know this, because then if none of you, or maybe like you did but then you forgot entirely, and then that means we have to start from scratch. Otherwise I can just go quickly. But then so you, Aisha, you were in process
Yes,
engineering.
yes, yes.
uh,
Yes, me and Ija did heat integration.
you and so how was your integration course?
It was okay.
Was okay. Okay, if when you say it was okay, that means we have to start from scratch. So so I'm now waiting for Shafiq's comments because he's now typing. Is there a link
It
to
wasn't
download
the best.
Symmetry? Oh, Shafiq, when I shared that announcement letter, and when you get it somewhere, you have to register, and then they will send you an email for you to download the whole stuff. Never use Aspen for energy before. Okay, okay. And then when we do this session, and then you will use this. Don't worry. But just I need to know. Maybe you need to start from the beginning. Okay, then I will start from the beginning. Yeah. So I have to start slowly. Think that's anything else. Any questions? For HYSYS, not only in this event scheduler, because I think it's very simple. Just need more factors, but then throughout the whole, I don't know how many weeks we have been doing this already.
It was a lot of weight.
A lot of weeks, yeah.
Yeah.
So
Doctor, can you share the earlier slides? I am actually not quite
earlier
how do I
slide,
say?
this slide,
The very very earlier slide.
very
Like
earlier
on the
slide.
first 2 or 3 weeks, you explained there was like a diagram where you as to guide where how you choose like Frank Robinson or
Oh, that one.
things.
That one.
Yeah.
I think that one you can. Where is that? You can Google, yeah. I can lead you to some books, yeah. Number one book is then Tauler and Synods. This one. So this is the books that you have to bring with you when you go to sleep and when you go to the toilet, basically. So this book, it has a chapter on thermodynamic, and then you can also go to chemical process design and integration, chemical process design and integration. This one is also
Oh,
another book that you have to go, you have to bring with you when you go to the toilet. There's one more book from Tony Kiss. Uh, Tony Kiss. Chemical process design, something. Don't remember. Book. This book. Ah, this one. Integrated Design and Simulation of Chemical Processes. So this book. So get this book and this book. Come on, this book and get this book. So these three books. So you have to khatam these three books. And then in these three books, they will talk about easy simple selection of chemical thermodynamic model. Yeah, I think thermodynamic model selection. Yeah. Images. So in Tonica's books, I think it will look like something like this, either like this or like this too. Yeah. But this is a good website as well. Yeah, this McCormick from the Northwestern University. So this one. So uh, ah, so you can start from here. So what components do we have? Is it polar or non-polar? And if it's polar, then we can go either do we have like electrolytes or non-electrolytes, and then we can see whether we have the electrolytes. We go to this. We use this electrolyte NaCl. If not, then we go to figure 2. Figure 2 in this case, figure 2, polar non-electrolyte. If its pressure is lower than 10 bar or higher than 10 bar, do you have the IJ? If not, and then you go to here. If you have the IJ, and then you go to this. So it's more like a tree diagram that you can just easily follow. Yeah, and this is the page where we can you can also go through this. It's a very good web page. Yeah, this one I recommend this. So you have this and this and this, and there's one more book which I recommend you to have. It's I think it's applied thermodynamics for process simulation. Thermodynamic for process simulation. Or dynamic modeling. Not this one. From that Hamburg people. Chemical thermodynamic for process simulation. So this one. Yeah, this book. So from Jürgen Gemeling. So this is the very excellent book when we want to go deeper into thermodynamics, and then they explain to you. They do also like a step-by-step calculation, so you can just go read this in your leisure time. So just take a cup of coffee and then some breads and then some teh tarik, and then you can just read like one page one day. Yeah, and then you do your one page one day one juz Quran, and then this one page one day, and that's it. So that should be enough for your life. So yeah, but basically, yeah, this whole thing in practice, this whole thing is it's just like a guidance for us to select the thermodynamic model, as in like if you want like to do like an academic study or something, or maybe slight research, academic research. But in practice, it's I think one of these people, they mentioned that nothing beats experimental value. What it means is that if we have experimental value, we better use this data to tweak the thermodynamic model. Yeah, because in this thermodynamic model there are many like binary interaction parameters that are just taken from the experimental of other people, uh, which come from a different operating conditions. They may be valid, may not be valid, something that we have to check. So if we can then find or adjust thermodynamic model that match our experimental data, or at least our condition, and then we better use this. Yeah, for example, yeah, if we have this vessel, for example, and then they have also the same vessel on practice, and then we know what is composition coming in, right? We know what the composition coming in, and then we know what the operating conditions of the vessels, and then somehow, yeah, somehow we have we must have the fluid coming out as the vapor, coming out and the liquid. So we typically have this a flow rate. Okay, and then somehow we can then take samples over here and then we analyze them, and then we get that compositions. Yeah, so we know the compositions over here, we know the flow rate, we get the compositions over here, we know the flow rate, and then we can obviously calculate what the compositions over here. So basically for this piece of equipment on the field, we know the mass balance of that, and then using the same information, we go back to our simulation, and then we try one model and then see if we can get the same compositions as above and in the below. Yeah, and if not, and then we can just easily change this fluid package. So we can just change this to what is available. Obviously in HYSYS there are not so many fluid package available, simply because they are dealing with typically, historically, this was developed to cater oil and gas industries. So and it's also not very much expanded anymore. But in Aspen Plus, they have much more elaborate thermodynamic models, which you can then combine and do whatever you want. So you have more freedom there than in HYSYS. And then, but nonetheless, in both cases, you can just select and then see which of this thermodynamic model fits best the data that you have in the, at least in this flash calculation, for example. So that's how we in a nutshell, how we try to find the suitable thermodynamic model, basically. Is it clear?
Yes, yes.
Okay, more questions. So this, yeah, don't forget to have this book. Can I just buy this or find the PDF somewhere? I don't know. This one is also a nice one, but I just more it's a like a bit more of like a copy paste from these books, I would say. But it's a good, like a Wikipedia page. Yeah, I mean any other questions? See, they have all of this stuff. Easy, nice and easy to read.
Like comic.
This one. Again, I said this whole thing is a skill. Yeah, and as with the other skills, we obtain skills by doing this repetitively and consistently. Hence, we can master the skill. I have to emphasize this again. You will not be able, yeah, be able to do process simulation by only looking at me doing the simulation. You have to do it yourself, and then you have to hit the wall by this unconverged. You don't know how to proceed, lack of data, how we then try to assume something. So all of these stuff is something that you have to experience yourself. So it cannot be taught, and so I'm really sorry. Yeah, it cannot be taught. It has to be experienced yourself, just like in swimming. Yeah, so I cannot teach you how to swim. You have to swim yourself. It's the same case. So well, I'm happy to listen to any of your problems when you do any of your simulations, whatever simulation that you would like to have. I would like to, I can help you and then guide you through the thinking process on how to develop the process simulation. But it has to come from you. You have to make a problem. You have to not being able to solve the problem, and then even though you have tried to solve it many times, but then when you're stuck, and then you can always come ask me questions. So that's at least what I can say.
Okay. Thank you, doctor.
Any other questions? We have 5 more minutes. So next week I don't know if it's going to happen yet, because if the symmetry is going to happen next week, which I doubt it, but depending on that, I think I need to prepare a little bit more official than our very relaxing Thursday evening, right? So I need to, at least I need to
Okay.
prepare 1 or 2 slides for each of the chapter. It's the same. Basically, we will go through the same step. But just I just want to make it a little bit more official. So I will need to have that time to prepare for the materials. And then maybe after that session, 6 sessions, and then we can continue our this nightly, weekly Thursday for the Aspen Energy Analyzer. Yeah.
Okay.
In the meantime, you can ask me questions as well. Yeah. So
Doctor, can I share your phone number with them? WhatsApp group?
oh, I thought everybody has my phone number already.
No.
No, okay, no.
Not everyone have your phone number.
I know that
So
you have mine. The Iza has mine. Shafiq has my phone number, and the rest is
not
Shakina.
everyone.
Shakina has my phone number. Stella no. Stella is the only one no. I guess, right? Means you with your teammates at batch, yeah.
Yeah, yeah.
Oh, okay, okay, okay. Um, okay, yeah, that is fine. Yeah, that is fine. It's just like if you all come and message me, and that will be like a huge burden. I prefer that we have this session and then where you can all ask me questions. So rather than
Yeah.
replying to each and every of your WhatsApp messages. Oh yeah, is the session office hour? Okay, I think I forgot to mention. It will be on Saturday morning. It's an 1 minute. Yeah, I need to check my. Uh, we plan to do it. 1 minute. Yeah, where's this guy? So we plan to do it at 10 o'clock Western time Indonesia, which in this case it's 11 o'clock in the morning. So 11 until 1 before Zuhur. So 11
Alright.
until 1, 2 hours every Saturday. So yeah, sounds good. Yeah, Shafiq. So um, yeah. So 1 minute. Where's that thing? So again, so the same case like we will do a selection of thermodynamic and then the analysis of degree of freedom and then the simple simulation we did, and then columns, recycle, sensitivity analysis, optimization, and then dynamic simulation and control as the in the last 2 sessions basically. Any other questions? No? Oh yeah, that will be in Bahasa Indonesia. So I'm really sorry, but then I think maybe I don't know, yeah, depends because I like I said I never teach in Bahasa Indonesia, so that will be my first time. So we'll see.
Rojak-rojak je, doktor.
Rojak-rojak je. Okay. I think all of you watch sinetron, right? So if you watch sinetron, that means you should be able to understand.
Pretty much.
Pretty much. Um, um, any other questions? Otherwise, if not, then we can just close this session, and then I'll see you next time, and then we'll just communicate in WhatsApp. Yeah.
Alright.
Okay.
See you
So
next time.
that's all. Yeah. Okay. So
Yep.
thank you. And then I'll see you next time, and then I'll see you maybe in the symmetry session. Yeah. Thank you.
Alright.
Bye bye.
Thank you very, very much, Dr.